Hi, welcome to In 5 Minutes. Next is to design the DC bias of a MOSFET circuit to meet the certain specifications which are given in the question. You can say IDQ, VDSQ, VR voltage drop across the source resistance is given in the question, and they have told us to design the entire circuit, that is all the values of resistance we need to find over here. They are given the transistor parameters as Kn dash, W by L and Vtn, and they have given the current in the bias resistance, that means R1 and R2 should be 20 microamperes. We know by the Ohm's law voltage is current into resistance, that is Rs, and the current is IDQ. So we know the value of VRS should be 1, IDQ is given as 0.25 milliampere, so this will give you the value of Rs, which will be 4 kilo ohms. So we have got the value of Rs. Now we can apply KVL to the output loop so that we can find the value of RD. Let's see. So when you apply KVL, it will be 5 minus ID into RD, because current is flowing positive to negative, we are living with negative sign, so minus ID into RD minus VDS minus voltage drop across RS, we can say ID into RS minus 5 equals to 0. So in this, what all values we know? We know ID, yes, it is given in the question. We know VDS, yes, it is given in the question. We know ID, we have found RS, so we can find RD. So when you substitute all the values, you will get the value of RD from this as 20 kilo ohms. So what we have done, we have found the value of RD, we have found the value of RS. Now we need to find the value of R1 and R2. Now by Ohm's law, we can say current into the total resistance, bias is R1 and R2. Since the current going into this is 0, the current flowing through these two resistance is the same, and the total voltage is 5 minus of minus 5, that is, this is nothing but your voltage, which is nothing but current, into resistance, which is nothing but your Ohm's law, right? So this will give you 10. Current is given as 20 microampere. What they have specified, current in the bias resistor should be 20, that is R1 plus R2. The current flowing through R1 and R2 should be 20 microamperes. So this is possible only when these values are satisfied, 26 microamperes. So this will give you 500k, that is the total value of the resistance should be 500k, then only the current flowing will be 20 microamperes, since the voltages are plus 5 and minus 5 volts. Now assuming transistor to be biased in the saturation region, we know the equation ID is Kn dash by 2 W by L into VGS minus VTN the whole square. Everything is given in the equation, what is not given is VGS. So substituting the values, you can find VGS as 2.45 volts. Why we need to do this is VGS is Vg minus Vs. You can find Vs from this, applying KVL over here. We can say Vs minus ID into Rs plus 5 equals to 0, or we can say Vs is ID Rs minus 5. So when I am substituting this over here, and how I can write Vg as R2 upon R1 plus R2 into 10 minus 5. Since there are dual supplies, we need to consider both the supplies. So this is your Vg and Vs. So when you substitute these values, what will have? VGS is Vg minus Vs. We are writing Vg as R2 upon R1 plus R2 into 10 minus 5 minus IDRS instead of Vs minus 5. So no VGS, we have found it as 2.45 volts. You can say 2.45 equals to R2 upon R1 plus R2, it is, we have found 500 kilo ohms into 10 minus 5 minus ID is 0.25, RS is 4 kilo ohms minus 5. So this will give you the value of R2, which is 172.5 kilo ohms. We know the total is 500k, so we can find R1 by subtracting R2 from 500k, so it should be 327.5 kilo ohms. So once you are done with, need to redraw the diagram. R1, R2, your MOSFET, you have plus 5 volts you have minus 5 volts. Here you have RS. What value we have got for RS is 4 kilo ohms. For RD we have got it as 20 kilo ohms. R1 we have got it as 327.5 kilo ohms, and R2 we have got it as 172.5 kilo ohms. This is how the design is completed for the N channel MOSFET. Thank you for watching in 5 minutes.